All right. Fun sock. Who did that?
Taylor came in and did something. Someone went over there and broke things. I don't know who's Taylor.
Good morning.
Taylor is someone who is a sophomore.
Fun sock Friday.
Thursday.
The 5th of February. You guys will be able to identify and use properties of similar triangles. What we're going to do on Wednesday, okay? Before we take that extra day to the crash course on factoring. Talking about similar triangles. So, not to be confused with congruent triangles, okay? Now, congruent triangles, going back to recap that, congruent polygons in general, including triangles, have the same side lengths and angle measures, right? The corresponding side lengths and the corresponding angles were congruent. So this triangle has a side length of 3, 4, and 5. The other triangle will have a side length of 3, 4, and 5. And we notice corresponding angles are congruent. Now we have similar polygons. The similar for similar will just be the tilde.
What's a tilde?
Okay?
Squiggly thing that's Spanish words.
Yes.
Tilde.
Oh, hair.
All right. So similar polygons have the same angle measures still. So it's still true that the corresponding angles are congruent, but they can be different side lengths. Now, even though the side lengths are going to be different, okay, we're still going to notice a similarity between them in a way. So the corresponding angles are still congruent, like we talked about, but the ratio of the side lengths of the corresponding sides are equal. Notice how we just did a section on ratios and we're using ratios? No way, right? Okay, I know, big brain. So in this figure, triangle ABC is similar to triangle EDF. Are they congruent? No, I should say triangle DF. I said EDF, triangle DF. They're not congruent because we see different side lengths. Now, if we notice, corresponding angles, are they congruent still like congruent triangles would be? Yeah. But notice we didn't have an angle for congruent triangles, did we? No. And this is why. Because we see the corresponding angles are congruent, but that's not enough to say the triangles are congruent. Now, if we take corresponding sides, and I say 3 to 6, and I create a ratio, 3 to 6, that should be equal to 4 to 8, another set of corresponding sides, which should be equal to another set of corresponding sides, 5 to 10. Now notice, I did the small triangle on top every time and the big triangle on the bottom every time. So if I take the corresponding sides, 3 to 6, 4 to 8, and 5 to 10, all of these should be equal. And what do all of those fractions reduce to? 1/2. So the ratio of corresponding sides are equal. The ratios are equal.
So that triangle is 1/2 the size of that triangle.
So the triangle is half the size.
The depth triangle is it?
Do you guys remember like when we did in the unit where we graphed a lot with all the transformations in chapter 3, how we had the scale factor and we made things bigger and smaller? Okay, this is kind of like that, right? It's kind of like we just took this triangle and we made it 2 times bigger. Or we took this triangle and we made it half the size.
Which one has the theme like?
Oh, the prime?
Yes, which one is
Yeah, it doesn't really matter. It depends on how you look at it. Okay? So, you guys remember how we had congruent statements? Like this triangle is congruent to this triangle? Okay? So, very similarly, we're going to have a similarity statement, okay? So, for the big figure above, we would say that triangle ABC was similar to triangle DEF. We would have said that before. And we have this thing called a statement of proportionality. To where if we go up above, we'd say, okay, well, with these ratios, 3 over 6, 4 over 8, 5 over 10, we'd say with the side lengths, AC over DF, AB over DE. So we can go over here in our statement of proportionality, say AC over DF is equal to CB over FE. The measure of these is equal to the measure of AB over the measure of segment DE. This is the same thing we did in the purple just a moment ago of saying 3 divided by 6 equals 4 divided by 8 equals 5 over 10. Saying, hey, if these triangles are similar, all the sides, the corresponding sides, are proportional. we can create a proportion that will be true for these corresponding sides. Because they're all going to increase by the same scale factor, is what the word we used before. Do you guys remember using the word scale factor?
I don't
Okay.
Nope.
All right, so for this example with these two triangles, can somebody tell me the corresponding sides? What sides would go together? This, and this. Okay, Jacob.
5 and 15, or
Okay, so what would 5 be? Side A, B?
yeah, AB,
And side what?
DE,
Okay, DE. Okay, somebody else give me another set of corresponding sides. Okay, Saren.
AC, and DF.
Okay, side AC and side DF. Okay, somebody give me the last set of corresponding sides. Okay, Aiden.
EF, and DC.
Okay, side EF and side BC. Now notice Aiden went second, the triangle that's bigger to the triangle that's smaller, where the other ones went smaller triangle to the bigger triangle. That's okay. For this part, it's okay. So now we need to do the ratio of corresponding sides. So that's the same part we did a moment ago, like the 3/6, 4/8. So we need to figure out if the ratio of these are the same, okay? Bill.
1/3.
Okay, you're saying they're all going to simplify down 1/3. So if we do these, we're going to get 5/15. We're going to get 12/36, and we're going to get 10/30. And we're going to say, well, these are equal, and they do all reduce to 1/3, and this is called the scale factor. We've seen that word before, like we said. Now, if you're going the other way around, big to small, would it be 1/3 anymore?
No, 3 1.
It'd be 3/1 or 3. Okay. Okay. It'd be 3. So we can now say definitively that triangle ABC is similar to triangle DF because the ratio of corresponding sides is the same. Okay, so you can say once we know the ratio of corresponding sides is the same, you can say, yeah, their triangles are similar. They have to be. Yeah.
Why do you put the question mark above it?
Great question. So why did I put the question mark above it? Because I'm saying, does it equal? Like we're asking the question, and then we say, oh, they do all reduce to the same thing, so they are equal. Now we can say that they're similar. Does that make sense?
Yes, that's
Okay.
what math is meaning.
Okay.
Put in the fraction form.
1/3.
Isn't it like 0.3?
Okay. What is the ratio of the perimeters? Well, how do we find the perimeter?
You count the sides.
You count the sides? Okay. 1, 2, 3. The perimeter's 3.
You add the lengths, the measures.
Yeah, we add the side lengths, right? We add the side lengths, okay? Okay. So what's the perimeter of triangle ABC?
27.
Okay. 5 plus 10 plus 2. The perimeter is 27. Very good.
So I'm right.
What's the perimeter of the bigger triangle DEF?
81.
81.
Right.
So let's try and take the ratio of these perimeters. What's 27 divided by 81?
1/3.
Divided by
No, 3/1. No, it's 1/3.
1/3. So note, this is the same as the scale factor, right? Well, let's think about it this way. Mathematically, what's happening is we could take 36 plus 15 plus 30 in any order, really, because it's adding. And we could factor out a 3 and get 12 plus 5 plus 10. Does a 12 plus 5 plus 10 look familiar? So mathematically, we just have the scale factor times the original, or the smaller one, to get to the bigger one. Does that make sense?
No, all those are the least common multiple.
Greatest common factor.
Greatest common factor.
Yep, would be our scale factor here. Now, once again, if I were to go big triangle to little triangle, would that reciprocate my scale factor each time? What does reciprocate mean?
Do it again.
Change.
Flip it. Reciprocate means to flip a fraction, okay? So would that reciprocate my fraction to 3/1 if I switch the triangles and I said, let's go from big on top, small on bottom?
Yes.
Okay. Now I'm typically going to be in the habit of doing the small on the top, the big on the bottom. Okay. That's just typically how I'm going to do that. It's not like it's the right way, wrong way. That's just how I do it. Does that make sense? So as long as you label and you're careful with what you're doing, it can be okay either way. Just know that if you're doing the big on top, small on bottom, and your neighbor's doing the opposite, you're going to have reciprocals of each other. Okay, Gucci?
Gucci.
Ken.
Why would you even look at your part?
Are you telling us to cheat?
No. I'm saying if you compare answers.
So that's called cheating.
No, comparing answers is not cheating.
Not from where I come from. Yep.
Where do you come from?
I'm gonna compare answers.
Come from Plattsmouth.
Come from a pigeon face.
Okay. Well, let's ask this question.
No, that's where I was born, Liam. Get it right.
Are congruent figures similar to each other? So we know if congruent figure, that means that the angles are congruent, right? We know the corresponding angles are congruent, and we can see this in our picture. But we also know the corresponding sides are congruent. Well, we said to be similar, the ratio of corresponding sides has to be the same, right? So, can somebody help me with my ratio of corresponding sides here?
1 to 1. 1
It'd be like 3 over 3, 4 over 4, and 5 over 5. And those all reduce to
1
1 over 1.
1. Do we have to put a question mark over the equals?
So, congruent figures, they're also similar to each other. So technically speaking,
Yes.
yes is our answer. They are similar to each other. But what's the scale factor?
One.
Just 1. Okay, because they're the same, yeah.
What's the scalar?
Scalar.
That's the question.
So if angles are congruent, they're similar.
Yes, if they, we'll actually get there, yeah. Okay. That's actually our next section. All right. Let's continue on. Determine whether these polygons are similar. If they are, write a similarity statement and find the scale factor. So what are we thinking? Are these triangles, these polygons, in this case triangles, are the type of polygon, are they similar?
No.
Why not?
That's 3/4.
Okay, the corresponding angles aren't congruent, but also, if we compare corresponding sides, 3 over 4, is that the same thing as 5 over 6? Or again as 5 over 6? No, they're super not, so these are not similar.
Well, 5 equals 5 over 6.
Do we have to put a question mark?
You're right. So
If it was 4.5,
Aiden
it
said,
would be a
hey
different
guys,
story.
voice off real quick. Hey, Aiden brought up a good point. But wait, 5 over 6 and 5 over 6, that's the same. So the ratio of 2 sets of sides are the same, but it's not all 3. Okay, it has to be all 3 sets of sides. All 3 sets of corresponding sides have to have the same ratio. So because only 2 of them do, not similar. Yeah, Aiden.
But then why did you beat me to this second equal sign? You didn't.
Oh, that's true. That should be an equal. You're right. Yeah.
Do we have to put a question mark?
Okay, great question. Do we have to put the question marks? Okay. When you're trying to prove if they're similar, yes.
Oh my!
If
Liam,
you
don't ask
already know
questions
they're
anymore.
similar, no. Because if you're trying to prove they're similar, you don't know if they're equal. If you already know they're similar, you already know they're equal, so you don't have to do that. Does that make sense? Great question. Okay, Sarah.
So why is what's work between the 5 6 and 5 6?
Because we're at first we're checking, but that one's kind of an easy check, right?
But it does. Why?
Why question mark?
If the question mark's only for us, then why are we coding?
So that way somebody else can see your work and know what you're doing.
Oh, I have no work.
Oh.
I never do.
Okay.
But what happens if you don't want people to show us also?
Yeah, we want.
All right, continuing on.
You both got wrong answers.
So, find the missing length if the triangles in each problem are similar. So I'm telling you, they're similar. So in letter A, we have 2 similar triangles. Wait, I only see 1 triangle.
There's 2 triangles.
There's 2. There's one inside of the other triangle, right? There's a triangle inside of the other triangle. So this triangle at the top is right up here. And then we have the entire big triangle.
How was the smaller?
Now,
Bigger.
we know these are going to be similar. So what's the ratio we could set up to solve for this?
1/4.
24 over 828.
Okay, so I heard a couple different ones. Okay, so we said we earlier we did corresponding sides over each other, right? So what side for the big triangle corresponds to the 24 for the little triangle?
6.
Okay, let me ask this.
Oh,
Or
no.
once.
30.
Yeah, 30.
30. How did we get 30?
24 plus 6.
24, haha, plus 6. So 24 over 30 is going to equal, we know for sure it's equal, not question mark equal, because it already says it's excuse me, it already says it's similar, is going to be equal to what over what?
4/5.
4/5.
Okay, it does reduce to 4 over 5, but what is it equal to for our other measures?
24 over 30.
28 over x. Now notice, we did the small triangle on top for both of them, right? And we kept the corresponding sides together, didn't we? Okay. Questions on the setup at all?
20, 30.
Questions on the setup right now? All right. So now as we go through and solve, we could definitely reduce to 4 over 5 and divide both by 6 if we want to create smaller numbers. Would that be pretty beneficial to us?
Yes.
Yeah, potentially, especially if we're not using a calculator, okay? So let's reduce and make this 4 over 6 equals 28 over x. How do we solve this?
Math.
And could I even reduce that more from 4 over 6?
Cross
Yeah, 2 over 3.
Let's make that 2 over 3.
I thought it was 4 over 5.
Give me 4 over 5. Why did I call it 4 over 6? Thank you. So we would cross multiply and get 4x is equal to, what's 5 times 28?
7, 35.
28.
Wait, why?
140.
140 because we're cross multiplying.
This is a more difficult way to do this.
That's like
Is it?
Yeah.
Oh, I know what you're saying. All right. So divide both sides by 4. Yep.
Yay.
Now, Bill, what did you do?
I just made it so 24, or that 28 was 4. I had to divide by 7, so I just multiplied 7 to
Okay.
5.
So he said 4 times what is 28? 4 times 7.
Yeah.
Well, that means 5 times 7 will be whatever x is, 35. Now, that can work here. It's not going to work on every single problem very well, just like we saw with the ratios last section, where like some of them get like kind of a lot more going on in the numerator and denominator, okay? So that can work on a problem like this. Now, let me ask this. Is there another way we could possibly set up our initial proportion other than this?
Probably.
If I'm asking, mate, probably. Okay. What if I told you there's actually quite a few ways we can set it up?
Oh, you can flip it around, like 30 over 24.
Sorry, say that?
30 over 24.
Okay. So another way we could do it, you could do 30 over 24. But if we did 30 over 24, what do we have to do?
flip the X.
X over 28. So notice, if I go horizontally, 30 and x, they're talking about both the big triangle, right? On the bottom horizontally, 24 and 28, we're talking about the small triangle. Vertically, 30 and 24, they're talking about these left sides. Vertically, x and 28, they're talking about the bottom sides. So whenever you do these proportions, as long as you set them up in a way to where horizontally and vertically things go together, it's okay. Here's an example of something I couldn't do to show you what I mean. So something I couldn't do on this problem, okay, I'm going to write it up here for now, but I'll erase it. Okay, I could not do 24 over x is equal to 28 over 30. If I do that, I will not get the same answer. If I cross multiply these, I still get the same answer because it's still 30 times 28 and 24 times x. But if I do that, I don't get the same thing. I have 24 times 30 now and x times 28. And if we look through this purple fraction here, if we look horizontally, 24 and 28, well, those both deal with the small triangle, so it seems to check out there. X and 30 both deal with the big triangle. But when we go and check through vertically, 24 and x, do 24 and x go together? No, 24 is talking about the side on the left of the triangle, and x is talking about the side where?
right.
At the bottom.
Bottom.
28 and 30, those don't line up either. 28 is talking about the bottom side, 30 is talking about the left side. So they don't correspond. Okay? So when you're setting up these proportions, you have to make sure they line up horizontally and vertically. Does that make any sense or no?
No.
Okay, here's some no's, here's some maybes, okay? Let's look at this next one and see and think about it, okay? So on B, matching dots are congruent angles. So these dots, these angles are congruent. So we know these triangles are similar.
Oh, wait, no, and I get it.
So what's a ratio that we could set up on this problem? Okay, before we simplify, what's the ratio we can set up? Saren.
Oh, I was going to ask a question.
Okay, what's your question?
I was going to ask if the unlabeled longer would be congruent with the other one because we already have two.
Sorry, what, buddy?
I was going to ask if the unlabeled corner at the top.
Oh, the angle?
Yeah.
Yeah, those other angles would be congruent. Yep, by the third angle theorem. Yep. Aiden.
Not 4 over 5 equals D divided by 15.
Okay, so Aiden said 4 over 5 is equal to D over 15. Is that what? So, would someone else have done it differently? Okay, Gage, what would you have done?
I would have did 5 over 15 is equal to 4 over D.
Okay, would anyone else do it differently? What if I told you there's more ways to do it? So you could also do D over 4 is equal to 15 over 5. Now, if we go through these and we were to cross multiply, are we doing 4 times 15 every time?
Yes.
Are we doing 5 times D every time?
Yes.
So we're going to get the same things. Now, how it works is vertically 4 over 5. We're dealing with the same triangle. So vertically, there's a match. They go together. Vertically, D over 15, same triangle. Horizontally, there's also a match. 4 and D, those are corresponding sides. 5 and 15, corresponding sides. Purple's okay. Pink. 5 and 15, corresponding sides. 4 and D, corresponding sides. Horizontally, 5 and 4, same triangle. 15 and D, same triangle. Same story here with blue. D and 4, corresponding sides. 15 and 5, corresponding sides. D and 4, 15 and 5. Yep. Horizontally, I missed that one. D and 15 are the same triangle. 4 and 5 are the same triangle. So as long as you have things lining up okay, things go together, it's okay. So any of these three could work. Show of hands if you want to solve the purple one.
Yay!
Show of hands if you want to solve the pink one. Show of hands if you want to solve the blue one.
Almost all in.
Okay, pink it is. All right. Cross multiply. 5 times D is 5D. 15 times 4 is 60. 5D equals 60. Spoiler alert, you get the same thing for the other two problems.
No, right?
Legit. 4 times 15 is 60. 5 times D is 5D. D times 5 is 5D. 4 times 15 is 60. You get the same problem no matter what. So from here, you still divide by 5. And D is 12.
Nice.
No? Yes.
It's like even.
Just look and see since two angles are congruent and you say, oh, 15 divided by 5, that's 3. So you say 4 times 3, and that's 12.
Yes, that is mathematically the equivalent of what's happening here. But that approach will only work when the numbers work out nicely. So if the numbers don't work out nicely, you're screwed unless you know how to do it. 12 what? 12 quesadillas?
Meters.
Yes.
12 meters.
Oh.
I wish it was 12
Me
quesadillas.
too, I'm sort of hungry.
I sort of hungry. Mr. Carlson, nice to meet you.
I had 4 quesadillas.
Ooh.
That's 12 miles. It's fun.
Okay, that's not miles. Nope, miles is MI.
Miles is MI with the dot.
Oh, get right.
All right.
Wow.
Letter C. I want everyone to try writing down a proportion. Don't blurt. I want everyone to try writing down a proportion that would work on letter C.
Wait, like the simplified one or the other one?
The one where we start with.
Oh.
That would work. Okay, Levi gave me one that would work. Okay, Levi says, hey, I could do 5 over 15 and have that be equal to 3 over A. Raise your hand if you had something different.
Aye.
Okay, Aiden, what did you have?
3 divided by 5 equals A divided by 15.
That would work. Raise your hand if you had something different.
Makes no sense, but it does.
Don't have anything different? All right. Well, either of those would work.
There's another way.
So from there, we solve them. There's plenty of other ways. From there, we solve them by cross multiplying. 5 times A, either way, is what? 5A. 15 times 3 is 45. So what does A equal, guys? 9. And this time do we have a label?
No.
No, it doesn't give us a label, so it's just 9 of whatever units it is.
Say alright.
I guess. It could be measured in cheeseburgers.
How about steak?
Ooh.
Oh, 9 steak or 2 steak.
We can do poll. Steak or cheeseburger. This one's better.
Alright, steak is better.
Yeah.
No doubt.
You can't have 9 steak. That's
No,
too
I
much.
look-
Steak
it
is
looks
good in
like you
moderation.
Steak is good all the time and every time.
No,
That is correct.
Steak is only good if it's cooked right.
Ireland gave you some judgmental look when you said that. Yeah, steak's good when it's cooked right. There's a good quote from my favorite Texas anime, King of the Hill. Okay, it's called Texas Anime as a joke, just because it's like it's a cartoon. It's just people in anyway. Okay. So King of the Hill, they're grilling one time, Dad and his son, and Dad's like, "Yep, they're done, medium rare." Son asks, "But Dad, what if somebody wants theirs well done?" "Well, son, we ask them politely but firmly to leave."
I remember that.
It's a grand one. It's a grand one. All right, you're sort of funny. I don't know you. Okay, anyone? Raise your hand if you want to help me set up D. D is in doggo.
I don't want to.
Okay, Kaya.
120 over 240
Okay, that would work. That'd be one way we could do it. Anyone have a different way they're curious to see if it would work or not?
Oh, I got one.
Okay.
70x is equal to 120 over 240.
No.
But it works though.
No, not if you say 70x, no.
Oh. I'm
All right.
Preston.
So could we simplify 120 over 240 before we go? Could we simplify 120 over 240 before we multiply? Sierra says yes. What do they go to, what do they simplify to?
1, 2.
1 half.
No 1, 2. Get it right.
85.
Nope.
Yep.
All right. From here, we cross multiply. 1 times x is x. 2 times 70,
140.
140.
X is cool.
So x is 140. Because we reduced early, we gave ourselves some nicer numbers. Otherwise, we would have dealt with a lot bigger numbers here, right? 1600 something. 1680.
Yeah, 16.
All right. Yep. All right, continuing on. We can find both x and y on this one. We can find both x and y on this one, okay? All right. All right, we can find both x and y. Can somebody set up a proportion to help us find x? Help us find x. Knowing that these triangles are similar. Saren.
16.8 over what? Wait, 12 over 16.8.
Okay, it could work either way.
8. 8 over x and then y over 21.
Right, so it'll also equal y over 21, but we'd want to do this as a separate problem. Okay, so from here, so starting off, we have 12 over 16.8, 12, small triangle, 16.8, big triangle, corresponding sides, equals 8 over x, small triangle, big triangle, corresponding sides. From there, we could cross multiply and solve for x, right? Max, you want to answer it?
No, not really.
Okay?
But we want to multiply that by 10 so that you don't have that.
You could, if you wanted, multiply the top and the bottom by 10 and call it 120 over 168. Or we can leave it as is, because if we type this in a calculator, it'll do our work for us, right? Okay. Which I'm going to suggest that route. Okay? So we type this in a calculator, we get 12x.
Can I get out my calculator?
Yep.
Cool.
Is equal to 8 times 16.8. 134.4. So now we divide both sides by 12. And x is
No way he does this.
Number.
11.2.
On that number.
Questions on x? I want you, right? I want you guys to find y now. When you have it or have questions, raise your hand. Give me a proportion we can use to set up this setup for y. Bill.
12 over 68 equals y over 21.
12 over 16.8 equals y over 21.
Yep.
Okay, that could work. Okay, could we use our new 11.2 that we found to be x?
Never. No.
Yeah, but do you want to use a number you just found if you don't have to?
No.
No, why not?
Because you could be wrong.
There's a potential we made a mistake for that, right? So if we made a mistake for that, and then we keep using it, that would make the mistake just kind of keep trickling on, a snowball, and become bigger. Whereas if we go back to the ones we know, 12 and 16.8, it would be independent of any mistakes we might have made. Okay? So it's a little bit of a safer way to go about it. Does that make sense?
Yes.
So you could do it the other way, but you're just risking that if you made a mistake, to double on your mistake. Okay? So here we cross multiply. That's not true, Liam. All right. 12 times anyone. What is that? 252 is equal to 16.8. Y. Divide by 16.8.
It's 15.
And Y is a nice even 15.
15.
15.
Ice cream cakes. Yes.
Okay, 15 ice cream cakes. Okay, 15 ice cream cakes long. All right.
So often.
The log though, not the circular cake. Okay.
There's an ice cream cake log.
Yeah, they're easier to cut.
When?
What?
I don't know, like forever.
Ice cream what?
Yeah,
Log?
yeah. It's like a log instead of like a circle.
I need a picture of you.
It's a thing.
How do they make that?
Little thing, Gabe.
I mean, the same way they make us.
That's really out.
Alrighty. What's up? Yeah, good luck. Alrighty. Hey, Chris.
I agree. F-A-B. Shut up.
We're gonna skip 7. All right, excuse me, F.
Dang it.
7.
No
I don't know where I got 7 from.
That's
It's not even the seventh
It'd be
one.
the 6th letter anyway. Alrighty. We're gonna do G though. What is the length of segment QT? And then part 2, if PT is 15, what's the measure of segment RT? Okay. So can anyone help me find the measure of segment QT? And no, you're not talking to your crush and calling him a QT. Okay. Jacob.
7. Ah, you're a QT.
Okay. How did you do that?
I'll do you.
Okay. Someone else want to help me with some math that's more consistent? Okay. Max.
Wait, so you want how to get there, right?
Yes, please.
So, RS is 3 and PQ is 9.
Yep.
So then, it would have to, ST would have to be 1/3 of QT. So you just have to multiply.
Okay. So because he's saying that 3 is 1/3 of 9, 4 is going to be 1/3 of whatever QT is, how would we set up the proportion? Kelly. Okay, that could be one you could do. 9 over 3 is equal to x over 4. One of many you could do. What is x in this scenario? What's it representing?
RT.
QT.
Q to t.
Wait. US is 8.
X is representing q to t in this scenario. So we're saying big triangle over little triangle is equal to big triangle over little triangle. Does it have to be 9 over 3? No, it could be 3 over 9, but then you do 4 over x, right? So thank you, Kelly, for helping me set this one up. Guys, learning how to set these up versus just trying to do them in our head is going to lead to more consistent success. Now, I'm happy if you're able to do them in your head and get them, don't get me wrong, but I want you guys to be able to still have this skill and still be able to do it, okay? So if we're focusing too much on doing it in our head and we're not learning the actual skill of setting up a proportion, it's going to hurt us down the road, okay? Does that make sense? Okay. I want you to at least know how to. So if you're doing it in your head and then you don't know how to do the work now because you never practiced it, that's a concern. That make sense? Okay. So now we're going to cross multiply. We can reduce first though if you want to go to 3 over 1. So you have 3 times 4 is 12. 1 times x is 12. Which means 1 times x is x. So x is 12. So 12 centimeters is the measure of segment QT. Maybe. Questions on part 1 of G.
Doesn't it tell us to find RT?
Now on number 2.
Oh.
Separate problem. If the measure is saying that PT is 15, what is the length of R to T? So what do we want to call RT for now?
Why?
Cool.
No.
Bill.
What?
Call it W.
Okay. So, what's going to be our proportion we set up this time?
Y divided by 15.
Okay, so you can do y over 15. I'm going to go over here to the left. Y over 15 could work equals what?
4 over 12.
Okay, we could do 4 over 12. Is there a chance we made a mistake on 12, though?
4 or 3.
I mean,
Or 3 or 4.
I have no idea.
Okay, so if we did y over 15 small triangle over big triangle, 3 over 9 small triangle over big triangle.
I didn't see the triangle. Oh, okay. I said
That would work. All right. So now we can simplify. What? Yep. 1 over 3. Cross multiply. 3y is equal to 15. Divide by 3. Y is 5 centimeters. So the measure segment RT is 5 centimeters. With this information, question, could we find QS and PR?
Yeah.
Sure. No, you wouldn't use Pythagorean theorem for that part.
We just add.
Yeah, you would subtract. Use the segment addition postulate.
No, the RST one.
Oh, yeah, you could. All right, questions on that, guys?
time for homework.
Hmm.
Ew. No.
Are you okay, Sierra?
Yeah.
Just trip sitting down.
All right, we'll go on to our homework.
That's okay.
I don't know how to do one.
don't do one.
I don't want to.
Can we just do
Bad boy.
Because there's like 3 the ones.
No.
Is it either 2, 3, or 7?
All the normal.
Don't do 1, 12, or 16.
Let's go.
1, 71.
Oh, thank goodness.
No.
Hey, guys, on 15 and 16, I want to give you guys a quick note.
What?
Okay. So on 15,
112.
here's your setup. Okay, it's like that, right?
You're really bad number.
You're a really bad double triangle.
Oh, I tried me. That hurts, doesn't it?
Okay, here's what we need to add. In the orange there, you need to add those angles are congruent.
It just does.
It does.
Just rotate the little triangle 180 degrees.
Not like 20 feet.
Then, on number 16.
You said don't do that.
Don't do that. That one's illegal.
Did I say not do that one?
Yeah.
Oh, yeah, never mind then.
Oh, you also said don't do 14 too.
Jaw to jaw.
Wait,
All
which ones are
in favor?
1, 12,
Don't do 18.
Don't do 1, 12, and 16. And here's our note on 15 that we need to mark angles B and H congruent.